Good afternoon, everyone. My name is Dominic Preuss. I'm the Director of Product Manager for our storage, database, and capacity products on Google Cloud Platform. So I'm very excited to be here today, day 3 of this amazing conference, to talk about database migration service on GCP. So as we've onboarded more and more large enterprise customers, and we talked about Target in the keynote, we've talked about HSBC and other large companies, they often have a dilemma about how to get their data into the cloud. And so we have a set of recommendations we give to people when they think about these migrations. So the first thing is, as customers are moving their data into the cloud, we want to make sure that they're realizing value all the way along. So we want to make sure that they identify which workloads to move first, get on track, get some experience, get comfortable moving that data into the cloud, and then that allows you to minimize the disruption to your business. So we'll take you through kind of a framework of how we talk about that and how we think about it, and then I'll bring up Pierre from Illuma to talk about how they do database migrations. So when we go in and talk to large customers about database migration, we focus on 3 phases of the approach. So the first one is assessment. So this is where you actually look at the data that you have, think about what would be most logical to move, and then we move into phase 2, which is doing the actual migration. So we'll talk about some strategies for doing migration, and the last one is validation. How do you know that your migration was successful? So phase 1, assessment. The first question is, what apps and databases need to move? So one of the things that's most interesting about my job is going into customers, and they say, I need to move some data to the cloud. I say, great. What data do you have? They're like, I don't know. So I'm like, OK, the first thing we need to do is go through and actually catalog and do some discovery on all of your databases. Once we have the full list of databases, we can look at which ones might be appropriate to move to the cloud. And this might be based on which databases actually work well in the cloud, which ones have managed services. So you're going to look at kind of what is the match or mismatch of your databases to what's available in the cloud. Once you've identified what some of those database workloads are that might move to the cloud, you need to understand the capabilities that are out there. So if you're, one of the things that we see is often a really big issue is if you're running older versions of databases, it's often more difficult to move those to the cloud. If you have an older version of MySQL or Postgres, you might not be able to move that into Cloud SQL because it doesn't support the same version. And so then you might not be able to take advantage of a managed service, and you might have to actually put that onto a GCE, a Google Compute Engine VM, and manage that yourself. So you have to make sure that the capabilities that are available on the platform match with the use cases that you have. Then you have to figure out what is the right path to the cloud. So if you're moving a database or an application, can that database or application accept downtime? Do you have to basically try to do a live failover migration, or can you accept an hour or 2 hours of downtime? Can you do it over a weekend? Can you do it overnight? What are the actual requirements of that application when you want to move it into the cloud? And the last one is, how well does the target support the application? So you might want to move an application that has a MySQL database, and that MySQL database might be supported by Cloud SQL, so you can move that database over. But for some reason, that application requires something that doesn't work well in the public cloud. Maybe it only runs on bare metal. Maybe it requires some APIs or access to underlying systems that make it inappropriate to run in the public cloud. So you need to make sure that the target of where you want to land your database matches what you need from that application and database. So phase 2 is the migration. So what you want to do is, once you've identified the applications and workloads that you want to migrate, you need to figure out what type of migration I'm going to do. So this is actually using the Gartner set of migration types, and we've actually added one because we think they forgot the most important one, which is retire. So the first thing you should do is look at all your databases, and the first thing you should say is, do I still need this database? Right? Are people using it? Can it be consolidated? Can it be basically retired? So do I even need to migrate that? We think that's a very important first step. The second one is replace. So another thing you need to do is look at your databases. So let's say that you're running an on-premise CRM solution that has a MySQL database. So your first question is, do I want to migrate this to the cloud, or do I just want to move to a SaaS offering? Do I just move to Salesforce? right? Do I move to a fully hosted solution? Like if I'm moving Exchange Server, do I want to go to a hosted Exchange offering? Do I need to move those databases at all? Or can I move to a full SaaS offering? That's option number 2. Number 3 is rehost. So this is basically moving that application and hosting it on GCE VMs. So when you move that data over, can you put it onto a PaaS offering, which is option number 4? If I can't, can I run it on a VM? So again, things that end up being really interesting here are really old versions of databases, less common databases. So if you have something like a MarkLogic, or if you're running a Neo4j, or something that doesn't have a managed offering today, can you put it on a VM and manage it yourself? And so that's option number 2, which is rehost. The next one is refactor. So when I talk about our customers that are coming to the cloud, I find that they break out into 2 camps. There's a set of people who have the right people in-house, feel very comfortable, and want to manage their own infrastructure. So they want to come and they'll actually use our IaaS offerings, our infrastructure as a service. But what we find is about 80% of people are coming to us because they're having trouble managing, they're having trouble hiring the people that are necessary to manage their workloads, or they're having some other reason that they don't want to manage infrastructure anymore. So they have a very strong incentive to try to move to our platform as a service offerings. So Cloud SQL, our memory store offering for Redis, those types of things. They want to get out of the business of managing their infrastructure. So the question is, can they move on to our platform as a service offering? So another layer up the stack. The next one is revise. So the first 3 assume that you're not making any changes to the application. You're basically picking up your application as is, running exactly the same way, and putting it in the cloud. This next one is revise and modernize. So this is, can you make some changes to your application to take better advantage of the cloud? So an example is, I have an application, it's currently running on MySQL 5.5, that's not offered in Cloud SQL. Can I upgrade that application to use 5.6 or 5.7 so now I can move that into Cloud SQL? Or I have an internal application, it currently uses Postgres. I'm about to grow out of my Postgres instance. I'd really like to move to Cloud Spanner. Can I actually re-platform that and rewrite that application to work on top of our platform as a service? And the last one is rebuild. If I have an application, it might be long in the tooth, it's missing a bunch of requirements, I'm just going to rebuild the whole application. And now you're in greenfield and you're not migrating anything. And now you can actually rebuild using some of our cloud-native technologies like Kubernetes, Istio, the cloud services platform, and actually take advantage of the full power of the cloud if you actually rewrite the application from scratch. So these are really the 6 different ways. So it's the 5 from Gartner, plus we've added retire, which we think is a very useful migration for people that are moving into the cloud. Then you get to the validation step, and this is really important. Once you've moved the data, you need to verify that that data has come across. Now, this might be as simple as doing a count select star on all of your tables to make sure that they're the same number of rows in the old database as in the new database. Depending on which database technology, you can do checksums on all the data to make sure that the data has come across. But you really need to make sure that that data has come over wholly. Then you want to do is then start to optimize. So you want to look at, okay, those MySQL database flags that I was using on-premise, should I be using the same flags in the cloud? Probably not. We probably want to use a different set of flags to optimize for our particular workload when running in the public cloud. We also want to do some performance checks. So obviously, once you have all the data over and you've checked all your tuning, you want to make sure that you are having an acceptable level of performance. Right? You want to make sure that something hasn't changed with the way that you were hosting it on-premise in the cloud. You want to make sure that your customers are still happy with the level of latency and performance that you're delivering from the system. So these are the general framework that we think about when we talk about cloud migrations, or database migrations. And so how does Google Cloud Platform help? So the first thing is we provide a foundation. All of our services on Google Cloud Platform are industry-leading in terms of performance, whether it be our VMs with persistent disk, whether it be Cloud BigTable or Cloud SQL. And so we have a strong foundation that scales, gives you industry-leading performance, and also gives you industry-leading networking. And so whenever you're doing these migrations, the thing that ends up always being the thing that you get stuck on is actually networking. How do you get network connectivity from on-premise into the cloud? How do you get network connectivity from your application into the database? So all of the tools that we provide around networking actually are key enablers of doing database migrations. That also helps when you can get the bytes there faster over the network. From the capabilities, so we're a number of features. So we're going to talk about our external master feature in Cloud SQL today. We also have a number of tools that we're working on, and then partners. So we spent a lot of time over the last year, year and a half, building out the partner ecosystem. So working with partners like Illuma and other partners in the space to make sure that all of those tools that you're used to using on-premise or in other public clouds work great on Google Cloud Platform, and so you can use whatever tool you're used to using. We don't want to force you on any particular tool. We don't want to tell you how to do your migrations. If you have a tool that you're used to using, we want to make sure that we have a great partnership with that partner, a great relationship with that partner to make sure that that tool works. And the last one is support. So obviously, enterprise-grade support. We now have 2 different types of enterprise support. So there's the first, which is the cost base, where you get different levels of support. And then we've gone to a role base, where you can basically pay for individual seats of support, depending on what's better for your customer. What's better for you as a customer, and what's better for your cost structure. And then lastly, we offer a number of enterprise support mechanisms. So we have our professional services organization. So we spent a lot of time talking about what the professional services organization that we've built at Google that can help you with these things. Obviously, the SRE books are our site reliability engineering team. We published the original site reliability engineering book, and we just published the second book, which is the workbook. And then our CREs, which is our customer reliability engineers. This is really interesting. If you are moving a large application, or if you're launching a large application, you can engage with our customer reliability engineering team, and they will sit down with you and talk through your launch plan, your run books. How are you going to support an outage? How are you going to deal with the various things that could go wrong when you do a launch? So we provide all of these services for people to be able to take advantage of as they're migrating their application or launching new applications. So we talked a little bit about tooling. So now we're going to talk about migration to Cloud SQL. So one of the most common patterns we see when people are moving relational databases to the cloud is this model where basically you have a MySQL database that is managed somewhere. This might be on-premise, it might be in another public cloud, but that's where your master is. And so the easiest way to get your data into Google Cloud Platform is to add a replica of that database in Cloud SQL. So in this case, for Cloud SQL, for MySQL, basically you can add a Cloud SQL replica that is speaking to a master instance, a master node, that is somewhere else. So this way you can replicate all of your data into Google Cloud Platform using MySQL's native replication. So you get all of the consistency guarantees and all of the things that are possible through MySQL via asynchronous replication, so you're not impacting your performance, to get your data into the cloud. Once it's into the cloud, you can then add a failover replica so that you have HA, and then you can basically trigger a failover to then move the application from speaking to your master instance that is somewhere else to the Cloud SQL replica, which was a read-only replica, which is now your master replica, and you have HA by having a second replica where that data is managed. So now you've moved all of your data from another location into Google Cloud Platform. You've now replicated it so that it's highly available, and now you can repoint your application to take advantage of that new setup. So one of the things that we advocate always whenever we're doing a migration of an application or a database is that we really encourage people to take the simplest possible approach. It's very easy to boil the ocean when you're trying to move data. So it's very important that you try to start with the simplest possible implementation. So the vast majority of databases, usually this is around 80% of all of the databases, you can move very simply with some downtime. So basically you have an existing database instance. You basically stop writes to that database. You can allow reads to continue to come in. You export that data. So if it's MySQL, it's a SQL dump. It could be CSV. It could be whatever data format. You basically copy that data into Google Cloud Storage, and then using Cloud SQL or whichever database you're using, import that data in, and then move the database across. So this is by far the simplest way of moving your data across. Now, this might be an hour of downtime. It might be 2 hours, depending on how much data. But if you're dealing with 100 gigabytes of data, smaller data sets, then this is a very acceptable way of doing this. If your application can be down overnight or over the weekend, this is by far the simplest way to do a database migration. Now, the key factor in that migration scenario that I just gave you is how long does it take to take that import and put it into the new thing, right? So if you are copying the data, so you've done an export of your database, copying it into Google Cloud Storage because of our network tends to be very fast. And so what the long pole of this process is basically how long it takes to get your data from Google Cloud Storage into your target database, whether that be Cloud SQL or Cassandra or whatever it happens to be. So here's some general best practices that we try to explain to people when importing database data. So the first thing is, when you import your data, don't include your indexes. Right? So bring your data across, bring the raw data. Don't try to bring over all your secondary indexes at the same time. So import your data first and then add your secondary indexes. This dramatically lowers the amount of import time for most databases. The second thing is do your best to import the data in primary key order. So try to make sure that your export is ordered by primary key so that when you're importing the data, it makes it as easy as possible for the database to insert that data. If you are using MySQL or Postgres, and MySQL specifically, it's really important that you select a instance type that has as much RAM as your, at least your largest table, if not your entire data set. By bringing all the data in on a really large memory instance, you basically can keep all of the data in memory, and it makes it much easier to write the data in. So use a much larger memory size instance initially than you might need to run production. You can always downsize it later, and so this will really speed up the import process and decrease the downtime that you have in the database migration. The second thing is use our SSD storage. So persistent disk, our block storage device, comes in two flavors. Magnetic disk and solid state. And so if you're importing into a GCE VM or into Cloud SQL, using this option will dramatically speed up your imports into the system. Another thing to remember is when you're using persistent disk, the amount of IOPS you get on your disk are dependent to the size of the disks. So make sure you use at least a 500 gigabyte disk to make sure you're getting the maximum throughput on that VM. And lastly, make sure you're monitoring. So you can watch things like IOPS, whether this be from your GCE VM or if this is in your Cloud SQL instance. You can do this via the Cloud Console or via StackDriver. And then obviously keep an eye on your read operations, because a lot of very high read operations might indicate that your database is paging, which will basically increase your import time. So these are all things to think about when you're importing the data to try to minimize the downtime when you're migrating. And then after you import, again, because you're in the cloud, you haven't bought a physical device that you can't resize. You can resize your database, make it bigger or smaller. You can turn on the binary logging as necessary. Turning this off ahead of time in Cloud SQL will dramatically increase your import times. And then add your indexes after the fact. Don't add indexes when you are importing the data. Add them after the fact. It's much, much faster and will save you a tremendous amount of import time. Now, if you're moving an application that can't accept downtime, you're going to want to look at using replication to actually move your data across. So as we talked about here, you're actually moving the data across. So we're going to replace that step with actually doing replication. Now, if you're doing like to like, if you're doing MySQL to MySQL, Postgres to Postgres, Cassandra to Cassandra, you can basically use the native replication. If you're doing something like MySQL to Postgres, or you're doing a heterogeneous migration, then some of the tools like Attunity, Illuma, some of the other partners can help you really with that workload because they can provide you replication that isn't native replication. So the idea here is that you're replicating all the data across, and then once the new instance has caught up and you know that the lag is sufficient, so if this can't ever catch up, you might have to stop writes for a small amount of time while that replication catches up. But assuming you can get to a steady state where there's very little lag, then you basically can move your application over and have it speak to the other instance. And therefore, you can have very low downtime migrations. Another workload that we talk about a lot is migrating Cassandra to Cloud BigTable or Cloud Spanner. For this talk, we're going to focus on BigTable, mostly because of there's lots of Cloud Spanner sessions talking about migration. But what we do is one of the most common use cases we see for Cloud BigTable is people wanting to migrate off of their HBase or their Cassandra clusters. So we see this as a very common use case for people moving to Cloud BigTable. One of the big questions is, if I'm coming off of Cassandra, should I use Cloud BigTable or should I use Cloud Spanner? So we've put together a little bit of information to help you choose between the two. Because Cassandra has a very wide variety of use cases. And so how you're using Cassandra will determine which cloud service you want. So you want to use Cloud BigTable if you're serving derived data, if you're doing batch ingest and analytics. So if you're using it as a true wide column store and you're trying to write data in and use it as an analytics cluster, then Cloud BigTable is going to be a better solution for you. If you're serving user visible and mutatable data, especially if you have multi-row transactions or you need secondary indexes, then you're going to want to use Cloud Spanner. So a way to think about this is if you are using if you're using Cassandra with local quorum to write to a single zone cluster with eventual consistency, then Cloud BigTable is probably the right solution for you and will give you cost advantage over Cloud Spanner. If you're using Spanner with each quorum or local quorums, but it spans multiple regions in the ring, then you're going to want to use Cloud Spanner to get the same level of functionality. So how do we do this? So you have an application that's speaking to your Cassandra cluster. The most common way that we see customers migrating and what we recommend is what we call a dual write structure. So basically, you have an application that's writing to some sort of queue. This could be a Kafka queue. It could be RabbitMQ. It might be some place on your application where you hold. And then basically, we recommend that you do dual writes. So you have two consumers of that queue that write the data to both Cassandra and either BigTable or Spanner. So what this does is it allows you to basically write data to both databases while the application is talking to Cassandra. Once you've gotten a sufficient amount of data into the Cassandra cluster, and it is basically caught up, then you can basically look at moving it into and switching the path. So here, if you don't want to run your own consumers, you could use Cloud Dataflow. You could use Dataproc to do this. You could also use Cloud Functions or some of our other serverless architectures. So we talked about Kafka. So some suggestions. You can use Apache Kafka if your writes are non-idempotent. I always get this word wrong. This is one of the most difficult words for me to say. If you need in-order message delivering is required, or if you need compatibility with the existing Kafka tools, Kafka Stream or whatever it happens to be. You can use Cloud Dataflow if your writes are idempotent. Try that again. Or out-of-order message delivery is OK, or it needs to be globally replicated. So then once you've gotten all the data written over, you've done an export to kind of get the bulk data, and then you've dual written. Now you can actually move your application to speak to Cloud BigTable and start to read and write, read the applications. You're still doing writes to both places so you can roll back, but now you can read the data from your new database source. Then your mission accomplished. Your migration is done. All right, so with that, I would like to bring up somebody who has much more experience than I do at database migrations. So I'll bring up Yair Weinberger, the CTO and co-founder of Illuma, to share some of the tools that they provide.
Thank you, Dominic. Can you hear me? Am I mic'd? All right. So I'm Yair, CTO of Illuma, as I mentioned, and we deal with migrations all the time, and a lot of it is to GCP as well. And I'm going to talk a little bit more in depth about database migration, especially the more complex use cases and the thing you can enter. But maybe before that, just a little bit about generally Illuma and data migration. So, and I'm sure this is not news to any one of you. We used to be on-prem. We used to have our compute on-prem. We used to have our storage on-prem, our database on-prem, and what happens now is we want to move. We want to move to modern technology. We want it to be managed as a service in the cloud. We want to use the best of breed technologies for every one of our workloads. Our applications are moving to containers. Our storage is moving to the cloud storage, which is infinite and much cheaper. And then our databases are also moving to the cloud databases. And this is what Illuma is about. So Illuma is, and what I didn't mention is new applications that just born in the cloud, it's very easy. You know, we create it inside a container. We use Cloud SQL, and we just let it fly, and it's just working out of the box. But whenever we are looking at a little bit bigger company that has a lot of legacy applications, some of them, the people who wrote the code, don't exist anymore or don't work for the company. Some of them has a lot of legacy databases, petabytes of data. I think one of the fun facts was how Evernote moved over 3 petabytes of data. All need to be moved. This is that dragon that needs to be tamed, and everyone who experienced that knows it could be extremely difficult and time-consuming. Sometimes even takes years. So just saying I want to move to the cloud can be quite difficult. And now when migrating, there are 3 types of migration, and I'm going to focus on the data migration part, which is what Illuma is focused on as well. There is the compute instances. We want to move our compute and workload to the cloud, our applications and services, and the data itself. Now, because this process is not atomic, it's not like we can start on-prem and then the next day we're full in the cloud. It takes time. It can take months. It can take years. While we make that move, not only we want to move the data, but we want to keep the 2 environments in sync. We want to make sure that whatever we have on-prem can be synced to whatever we have in the cloud, and sometimes even back, sometimes even vice versa. And that's where Illuma comes in. And Illuma have built the tooling and the product as a service in the cloud to migrate a lot of the on-premise data from databases, from storage, from data centers or enterprise data warehouses into the cloud, and actually all clouds, but Google in that context. So, how does a data pipeline or how does a migration data pipeline look like? And this is a little bit of a peek under the hood. So you need to have a lot of connectors, connect to anything, and that could be RDBMS, which is the focus of this talk today, and what I'm going to show soon, how we migrate a database instance. But that also could be files that can exist on FTP servers, on some cloud storage that we might have put them there. That could be events that are coming, event streams that are coming from mobile devices, coming from applications, and they could even be the SaaS vendors that we use, because already not all of our applications are inside the org. Some of them we use Salesforce, we use Marketo, HubSpot, all of those new SaaS vendors. We want to make sure we are able to read their data as well. So a lot of connectors. And then once we get all of that data in, we of course put it in the message queue. Illuma under the hood uses Kafka, but that's of course not mandatory. We do believe it is currently one of the best options in the market. We want to be able to transform or modify the data that goes through, and that's what we call the code engine, the ability to run code on the data that goes through the stream. And we want to be able to know how the data looks like. What is the schema? So again, and I'm sure many of you have used Hadoop in the past and are familiar with the schema on read concept, where we just push everything into that data lake and then take care of the schema when we want to read the data. I believe that this is created a lot of problems, because sometimes the schema changes over time. The schema, there is a skew, and if we only find out about it when you try to read the data, we might be in big trouble already. So we need to understand and maintain the schema or how the data looks like. And that can be either imported from the source or inferred from the data itself. So if we read data from Oracle database or anything that has a schema with it, that schema can be imported and translated. If we are reading data from files or from event streams, sometimes the schema needs to be inferred from the data itself. And then we need to make sure we know to put the data wherever it belongs. So I want to show you a little bit lift and shift use case. All right. Can I get the other screen? Great. So this is the Illuma product. And what I want to show you is how we take a database, MySQL on-prem. Looks like I will need my VPN here. Sorry about that. And take that and move it to a MySQL Cloud SQL instance in the cloud. And I actually want to add a little bit of a twist here, because as Dominic said, sometimes there are just very simple migration where we can just enable replication between the master on-prem and whatever the Cloud SQL that we have in the cloud, and let the MySQL application take care of it. But in that, I want to introduce another very common concept of sharding. My on-premise MySQL database is sharded, and I'm writing to 2 different shards, but there is no need to keep the sharding when I'm moving to Cloud SQL. When I'm moving to Cloud SQL, of course, I can make the instance much bigger. I already have highly available out of the box. So I want to ditch the sharding, and I want to write everything to the same database instance. It makes my applications more maintainable. It makes my querying the data more maintainable, because I don't need to query from multiple shards. So there is a little bit of a twist. If I just enable replication as is, I will keep the sharding in place. So what do I do here? I started my Cloud SQL instance of MySQL, which is here, and I configure it as a target for Illuma. So very simple. I configured that that's the same Cloud SQL as the target for Illuma. And then that I already did, but the next thing I need to do is just to add the MySQL data source or sources. So this is, again, very simple. And that can be, by the way, that can be Oracle. That can be pretty much any cloud database, SQL Server, Postgres. So I can also do lift and shift or lift and modernize the same way. In that case, if I take MySQL, and then all I need to provide is the connection details, the type of replication. Of course, change data capture is the most recommended one, but it can be incremental replication or full dump load replication as well. And the list of tables to replicate. Of course, I can leave that empty, and then it just means I'm shifting my entire database. I don't want to just move a specific subset of tables. And once I got that done, once that is configured, I have my data running and streaming. I can even, I can click on it. I can see live samples, whatever comes through the stream. So in that case, I've made a very simple use case. So I have my on-prem database. I have 2 shards, which are in one table, which is transactions. And every shard has only 1 row in it. Of course, in reality, it's much bigger than that. Once I set up that connection, what Illuma will do under the hood is it will start replicating the ongoing changes over time, and it will create a process to dump the entire data set. And then no matter if it's 1 gigabyte, 10 gigabyte, 100 gigabyte, or a terabyte, that process will happen under the hood. It will be optimized to migrate the data as best as possible. Take into consideration a lot of the things Dominic mentioned earlier about when to create indexes, to import by the order of primary key, etc. So all of these are, you're already getting that immediately out of the box. And then what I also set up is I've just set up a process that continuously updates the amount on my 2 orders. So as I mentioned, we do want to take to make sharding and to take those 2 shards and put them into one table. But those shards can have conflicting primary keys. Those shards can have the same primary key in shard 1 and shard 2. So what we do is here we leverage the Illuma code engine that I mentioned, and we change the data as it's going through the stream. And that's why we couldn't use just simple replication. And it's really a one-line module. All it does is it takes the shard from the metadata that Illuma attached to the data and put it in the event itself. So I can actually get live sample from the data. In the metadata I have, this is like shard number 2. And now I'm testing it. I'm just adding a shard ID field to the data itself. And that shard ID, I can see it was added to the data. So if I go back to MySQL, so on-prem we've seen the data just has ID created an amount fields. On the Cloud SQL part, we do have the shard as well. So we have shard 1 and shard 2, and we have data from both shards, and they don't override each other because the shard is considered to be as part of the new primary key on the target. All right, so we got that going. It's replicating continuously. It's very nice. Now I'm moving my application. Unfortunately, again, it's not very simple to move the application. Sometimes I cannot move the application at once. I need to move the application in parts. So let's say what I did is I moved the part that only writes to one of the shards. So I'm going to change it. So right now I'm updating both shards. That's my demo application, which is updating the shards. Of course, that is now disconnected. Let's see if I can restore it quickly. This is a real life demo. All right, so I was updating both shards. Now I'm only going to update shard number 1 because I migrated the application from shard 2. It's already working directly with Cloud SQL. So it no longer updates my on-prem database. And the only thing that's being updated in my on-prem database is shard number 1. However, I also want to make sure that I'm not wrong. So I want to make sure that I didn't mess up. I want to make sure that there is nothing left in that hodgepodge of servers that I have on-prem that's still writing to shard 2 on-prem, because I want to be confident and validate that I actually did the migration successfully. So what I'm going to do is I'm going just to add another small code engine piece in the module that I created. I'm just going to comment that out, which says, OK, if I'm reading data from shard number 2, let's raise an exception. Let's say, OK, I'm not allowing any more updates on shard number 2. That will give me two things. One, it will give me the visibility that it happened, but it will also stop the data from moving, because I probably don't want that data moving. Now, I can also move that later, but for now, I want to stop it from moving. And let's just make sure that it's working. So we got here a shard number 2. And now when we run test, we see that updates on-prem are no longer expected. So that's where we don't want that data to move anymore. So I'm going to deploy my code. And now it's still all fine, because we are not moving any data to shard 2 because we changed the application. Now, let's simulate our rogue application, the one that we forgot in the data center, that is going to update shard number 2. So it's going to insert, what I'm going to do here is I'm going to insert a new transaction to the on-prem databases for shard number 2, which is not supposed to happen. And then we'll see how we deal with it. So that's what I did. And while that is populating, I actually want to show you another nice element, which is a live visualization of the data stream itself. So part of the Illuma product is the ability to visualize everything that's coming in from the data stream live. So you can see the source, you can filter on the data itself, you can even see the events themselves. And this is looking nice and also very useful for gut check. So this is a more high volume system that actually streaming data in live. I can filter on only events that are coming from iOS or mobile, for example. I can actually see those events. And this is, except being a nice eye candy, it's also very useful just for gut check. Am I getting what I'm expecting to get? Is that data really make sense? So going back to our rogue application that updated the shard, by now we have already read that data, and what you can see is we have wrong data in our what we call the Restream Queue. So this is where we handle errors. We can see that what happened, you got an event, that event says shard 2, that's not supposed to happen. We did something bad. We have still have an application. We need to find out where it is, which server does it sit on, why is it writing those events into my old on-prem database. So that's part of our validation step. And I can actually find out exactly which application that is, what is it writing. It makes it very easy for me. The fact that I actually have the sample and the data itself makes it very easy for me to find out. And once I'm satisfied with it, I'm saying, OK, I found that application. I can just purge. I can either push that data back, or I can just purge all of this data and throw it away. And I'm saying, all right, now I'm successfully migrated that shard. I can move on to migrate the other shard as well. So this was a very simple use case of lift and shift migration, of taking data from MySQL on the source. And again, this was we already saw a couple of snags that you can hit while only doing that very simple lift and shift. Again, when you're moving your real enterprise data set that has thousands of tables with a terabyte of data, that, of course, can be much more complex. And then once you did that, it's also very simple to do lift and modernize instead of lift and shift. So I would take that MySQL, I just replace it with Spanner exactly the same way. So even I move to Cloud SQL, now I'm putting Cloud SQL there in the source, and I'm putting Spanner here in the target, and all of a sudden I can handle 1,000x more transaction volume.